Hi, you guys. So obviously I'm not at school today. I am at a horror convention helping run registration. So Miss Korosek is with you today. She's going to show you this video and she's going to pause along the way as I ask her to so that you can make corrections and copy notes and try out problems. So first up, if your name is circled, that means I am missing quiz 1 from you, and you need to make sure and go to the tutor center to take or complete that quiz and then turn it into the tutor center. Please do that during an off period. Here's third hour. So I had a few of you guys go into the tutor room and work on unit 0 quiz. That was the really long one with 52 questions. The unit 1 quiz is 7 questions, one side of one paper. So if your name is still circled as of yesterday, eighth hour, I did not have that quiz from you. So if you went in at the end of the day, you may have already turned it in, but please take care of that if you are here today. All right. So you're going to correct and turn in your homework in just a second. Miss Korosek is going to pause this video and you're going to correct your answers. I'll reveal them in a second, but please make sure that your problems show work. I want to see distribution, combining like terms, addition and subtraction, division and multiplication, and then your solution. If all you have is a solution, please keep your homework and fix it so that it does show work. I don't want incomplete homework. Once you have checked these, please turn in the homework to Miss Korosek. So Miss Korosek, please hit pause now. All right, welcome back. So now we're going to take a look at however you remember what it is that you need to do in your planner. Homework 1.5 is going to be to complete today's classwork, and whatever you don't get done is homework. And then don't forget your quiz corrections from quiz 1 are due on the 15th. Here's our calendar. So today, literal equations with the sub. Next Tuesday, you will be map testing. And I'll give you a homework of the pre-quiz. On Thursday, we'll have quiz 2. It'll be pretty short, but it'll get me ready to know what to review at the unit review for test 1 the following week. All right. So let's start with this warm up. Ms. Korsek's going to pause again here in just a second. I want you to try these two on your own and then think about what is the same and what is the different between these two. So please hit pause now and give the students a few minutes to attempt these. All right, welcome back again. Let's take a look at these. So if I want to solve for x, what that means is that I need to isolate x, get it by itself. So I'm going to add or subtract what's subtracted or added. So let's add 5 to both sides. Clean it up. 2x equals 18. So this is your given. And this was the addition property of equality. Now I have x multiplied by 2. So I'm going to divide by 2, divide by 2. That's called the division property of equality. And that's going to leave me 2 divided by 2 is 1. X equals 9. That's a 9, not an A. There we go. All right, in this other one, it's actually the exact same equation, except that instead of 2, I have an A. The x is still an x. Instead of a 5, I have a b, and instead of a 13, I have a c. I'm going to do the exact same steps. So I want to solve for x. Decide on which variable you want to solve for to begin with, and then I need to add and subtract anything to move it away from there. So same thing as I did with the 5 over there, I'm going to add b. However, when I clean this up, I end up with ax equals, now c and b are not like terms. So I'm going to end up with c plus b. Now we tend to want to put these in alphabetical order. We'll do that at the end. All right, then our next step was to do the division property of equality. Remember, I want to get x by itself, so I need to get rid of that a. The way that I do it, a is multiplied by x, divide by a. A divided by a is 1. That leaves me with x equals, let's put them in alphabetical order now, b plus c over a. Okay, so that is how we solve a literal equation, an equation with more than one variable, by using those opposite operations. It works just like what we've been practicing. So what's the same? All of the rules that we've been using, the given, the distributive property, like terms, addition, subtraction, multiplication, division gets us to our solution. However, now we're dealing with variables instead of numbers. So we're going to have less constants to be able to put together. X was 9 in the first case, but since we don't know what B, C, or A is, we can't actually simplify that anymore. So your final answers are going to turn out a little more complicated because they're going to have variables in them. All right. So pull out your notebooks and whatever you take notes in. And then if you haven't already done this, please, please put away your phones and your headphones. I know it is so tempting to pull those out or just leave them in, especially with a substitute in the classroom, but I really want your phones and headphones away. Please pay attention to this lesson, especially because I'm not there. So follow along. All right, 1.5 literal equations. We're going to recognize equations, with variables on both sides. Okay, we're going to rearrange, not recognize. Rearrange equations with variables on both sides. Sorry about not changing that. All right, let's take a look. So let's start off. Oh, I have a little triangle here. Let's start off by reviewing what we had in 1.1 and 1.2. All right. So in 1.1, we talked about splitting the sides. Now it's really important that we mark the variable. We want to know which one we're solving for because now there is more than one. We're going to use those opposite operations and keep it balanced using justification. And we're going to clean it up and remember to solve for a plus 1x. So we're going to distribute. We're going to use like terms. We're going to use addition, subtraction, division, multiplication, making sure to show everything on both sides. And then we're going to solve, recognizing that from the lesson 1.3, I should move to blue, 1.3, we talked about that often we have one solution, but sometimes we'll have no solutions or infinite solutions. All right, here is the first set of notes. I'm going to see how much I can. Nope, that's probably all I can get in there. So please hit pause and take this first set of notes, read what's in blue, copy what's in black. All right, let's talk about this before we get to these fraction coefficients. A literal equation just means more than one variable, different letters, and you're going to solve for one variable. So here it's really important that you choose the variable for which you're solving or isolating. You're going to move everything else away. So if I had a plus b equals 2a minus 5, I want to get those a's together and the b and the 5 on the other side, along with dealing with that 2 that's in there. So I'm going to use all the same rules. I just am going to end up with a b in my answer. It's like solving for y equals mx plus b. This is the slope-intercept form that some of you guys are familiar with. We'll be using that a lot. All right, here's the next set of notes. Please hit pause. All right. Fraction coefficients. Fractions are division. Just don't forget that. You can separate or combine them. So take a look here. If I have x over 3 in example 1, I have a ninja 1. So here's that little ninja 1 guy, right? That really is 1x over 3. But then I can pull out that fraction. I can make that 1/3 x. So x over 3 is the same as 1/3 x. If I have, let's go across. Number 2, I have m times v squared divided by 2. Really, I have a 1, so I kind of ignored the middle step there. I have a 1mv squared over 2. My ninja 1 is there. But then I can pull out the 1 over 2. It's the equivalent of 1/2 mv squared. That makes moving things around a whole lot easier. Look at number 3. 3 is an actual real world example. We have the area of a triangle is 1/2 base times height. And many of you actually know that formula is base times height divided by 2. Well, that 1/2 is where that division comes in. It's technically a 1 times base times height, but the ninja 1 goes away and you get base times height over 2. The volume of a triangular pyramid is 1/3 the area of the base. That's why it's actually a capital B there, times whatever its height is. But I can take that 1/3 and turn it into a denominator. 1/3 base times height is the same as base times height divided by 3. So recognizing those fraction coefficients are really helpful when you rearrange literal equations. All right, last one. Please hit pause. Copy this down. We're going to work these 3 problems, so make sure you leave a little bit of space. All right, we're back. So what we have now is an inverse property of multiplication rule. I'm gonna make this a little bit skinnier. Okay. We can call it IPM for now. We multiply a fraction by its reciprocal, it always equals 1. So let's look at one of those really quick. So if I said 1/2 times 2 over 1, 2 divided by 2 is 1, 1 divided by 1 is 1. That's all equals 1. If I said 3/5 times 5/3, right? 3 divided by 3 is 1. 5 divided by 5 is 1, and 1 over 1 is 1. So if I multiply any fraction by its reciprocal, its flip, then I'm always going to get 1. So let's take a look at these. If I have area of a triangle is 1/2 base times height, and I wanted to get that 1/2 somewhere else, I could multiply by 2 over 1. But if I do it to one side, I need to do it to the other side, right? 2 divided by 2 is 1, 1 divided by 1 is 1, and that leaves me with 2 area of a triangle is equal to base times height. Okay, I've rearranged some things. Twice the area is equal to the base times the height. Take a look at this one. X equals 1/5 y. If I multiply that by 5 over 1, and I do the same thing to both sides, right? Multiplication property of equality, I get 5 divided by 5, 1 divided by 1, and I end up with 5x equals y. Now, technically, there's a ninja 1 under there, but I don't need to write that in. It could just be 5x is equal to y. So on this one, we have a grouping symbol, but watch what happens. If I multiply, actually here, let's just scoot this out. Make a little room out here. If I multiply this by 3 over 1, and I do the same thing to the other side, look what happens. 3 divided by 3, 1 divided by 1, I end up with 3f is equal to g plus h. I don't actually need to distribute that. So I could absolutely have distributed that f equals 1/3 g plus 1/3 h. But then the way to get rid of those 1/3 is to multiply by 3, right? Multiply by 3, and I still end up with 3f. Okay, 3 over 1. 3 divided by 3 is 1, g. 3 divided by 3 is h. Oops, plus h. So I could go the long way around and actually do some distributive property, but it's a whole lot easier if I have something that's grouped just to go ahead and multiply by that fraction out front. Okay? All right, let's move on. So let's do a couple of practice problems in your notebook before Ms. Korosek hands out the worksheet that's going to be today's practice. We're going to solve for y. So the first thing that I'm going to do is recognize that I need to solve for that y. I'm going to split my equation. I'm going to give you a second actually to copy that down. All right, 2x plus 3y equals 10. That's my given. Okay. And I want to get that y by itself. So I'm going to add or subtract whatever's subtracted or added, but I need to move that whole 2x. So I'm going to subtract 2x from both sides and clean it up. That leaves me with 3y is equal to 10 minus 2x. All right, I can't combine those. Those are not like terms. But now I need to get my y by itself. It's currently being multiplied by a 3, so divide by 3. Divide by 3. Y equals 10x minus 2, or sorry, 10 minus 2x over 3. Now I could convert that. That would be the same as 1/3 times 10 minus 2x, recognizing that fraction coefficient. But notice it's all over 3, so the 10 minus 2x is all times 1/3. I could split it, so I'm kind of showing you a little more math than necessary now. I could go 10 over 3 minus 2 over 3x, right? So I could also split it, which would kind of be the distributive property there. So lots of choices here. This is a perfectly fine answer to stop there for now. The other piece is, technically, as we start to talk about order, this is going to be a minus 2x plus 10, constants come last, over 3, right? Let's take a look at another one. This time we're going to solve for p. This is our given. Please take a minute and write that down. All right. So I want to solve for p. There's only one p in here, so I'm not really going to have any like terms dealing with the p, but I need to move everything away from it. So I'm going to add and subtract what's subtracted and added. So I need to subtract a 2a, and I need to add a 5. So on the other side, I need to subtract a 2a. Notice that I'm putting a's under a's. And then I actually don't have a number over here. Oh, I do have another p over there. Okay, so then I'm going to go plus 5, and I'm going to clean everything up. So let's see where that leaves me. So plus 2a minus 2a goes away. Minus 5 plus 5 goes away, and that leaves me with a 4p is equal to 6a minus 2a is 4a plus p plus 5. I need to get those p's back together though. So how do I move a plus 1p over to the other side? We talked about variables on both sides. I'm going to subtract 1p from both sides. Clean it up. That leaves me with 3p is equal to 4a plus 5. All right, now I have all my p's on one side, but my p isn't alone. Remember, I'm solving for a 1p. It's currently multiplied by a 3. So let's divide by 3, and that leaves me with p is equal to 4a plus 5. I like that the constant is last over 3. Now I could still mess with this, right? I could recognize that that's a fraction. So this would say p is equal to 1/3 times all of 4a plus 5. Or I could actually split it and say p is equal to, so I'm pretty much distributing, 4/3 a plus 5 over 3. So if that's making sense, that's awesome. But in the meantime, this is a perfectly suitable answer. Okay. All right, last practice problem before you try some on your own. The formula C equals, 5/9. I don't know what happened to my 5/9 there. Probably somewhere else randomly on the page. There we go. 5/9 Fahrenheit minus 32 expresses Celsius temperature in terms of Fahrenheit. Let's solve for F. So C is Celsius, F is Fahrenheit. So let's start. Let me see if I can move this over. There we go. All right. So the first thing that I want to do, I'm actually going to split this up. Let's create a little more space here. Cool. Oops. Now I'm just really messing things up. There we go. Okay. The reason that I wanted to create a little space there is because I want to multiply by the reciprocal. Let's multiply both sides by 9/5. 9/5. 9 divided by 9 is 1. 5 divided by 5 is 1. That leaves me with 9/5 C is equal to F minus 32. Because water freezes at 32 degrees Fahrenheit, but freezes at 0 degrees Celsius. I'm going to move that C up a little bit. I don't want it to look like it's in the denominator there. Okay, so now I need to solve for F, so I need to add 32 to both sides. Add 32 to both sides. And I end up with 9/5 C plus 32 degrees, right? Because I need to crank it up 32 degrees to make it match the freezing point of water, is equal to F. Okay, I can also rewrite this in the other direction. I certainly could say F is equal to 9/5 C plus 32. Okay, if you liked it better that way. So we are using the exact same rules we've been using to solve other equations. So this is the subtraction property of equality, the division property of equality. And then I've just shown you some ways that you can deal with fractions. This was our given, and then we use the addition property of equality, the subtraction property of equality, the division property of equality, right, to get to our solution. Here, we use the addition property of equality. And then this would be actually the multiplication property of equality, or let's look back, right? We said that the inverse property of multiplication is when you multiply by the reciprocal. So the inverse property of multiplication, IPM, but MPE works just fine too, because really I'm multiplying by 9/5. Same thing on both sides, right? So now Ms. Korosek is going to hit pause for quite a while, and you guys are going to work on this worksheet. The first, before you hit pause, the first page is just one-step problems. So let me actually demo the first one for you, and then we'll move on. So if I'm solving for W here, I need to get that W by itself, which means that area equals length times width. That length needs to go away. So how do I get rid of a length that's multiplied? I divide. So all I'm looking for you to do is recognize that area divided by length, I'm using a cursive L so it doesn't look like a 1, is equal to width. I solved for W. So these are all going to be one-step equations. You're just going to multiply or divide, or in this case, you're going to use the addition property of equality. All the rest are multiplying and dividing. On the next part of the page, they're going to be multi-step. So we already did a equals 1/2 base times height. We started that one. In this case, you're going to solve for height. Okay, so you're going to use the opposite operations to get to height. Some of these have addition properties, but most of them, oh, there's one that needs you have to get rid of the n first. So remember, if you divide by n, you can have, that's an S, that's a weird S, over n equals a plus 1, and then get that a by itself. Okay, so you should be able to do this. Ms. Korosek is going to hand out this worksheet now. You're going to continue working on it in class for the remainder of the period. Anything you don't finish, oh, this should be a 1.5, that was my bad. Anything you don't finish is going to be homework. That homework is due when I see you next. Also, don't forget quiz corrections, or if you haven't taken the quiz yet, quiz corrections are due on the 15th. Bye. Have a great weekend, and I'll come back with great horror stories to share with you.